In this video, we're going to do an introduction to annuities. Now, previously we've talked about simple interest and compound interest, and we've been able to deal with situations like where you put money into a certain account. Let's say you put $5,000 into some account that gets a certain interest rate, okay, maybe 7%, that's compounded a certain number of times per year, maybe compounded daily, 365 times per year, and we can figure out how much money will you have at the end of, let's say, 10 years. Okay, so you put this big lump sum at the very beginning and you wait and you let that grow. How much money do you have over time? Well, usually when people are trying to save, for example, for retirement, they don't just put in one big lump sum and let that grow. Usually what happens is people will put in a certain amount of money every month, let's say, maybe $200 every month, and let that money grow over time. Okay, and that is really what they've established is an annuity. Okay, a sequence of equal payments made at equal periods of time is called an annuity. Okay, now these have to be equal payments. Okay, if you're putting in $150 one month and $225 another month, then that's not an annuity. Okay, and it also has to be equal periods of time. So you can't put it in once, then 3 weeks later again, then 2 weeks later, then 5 weeks later. It has to be equal periods of time. Let's say, for example, at the end of every month. Okay, now the time between payments is called the payment period. So that would be 1 month in that scenario. And the time from the beginning of the first payment period to the end of the last payment period is the term of the annuity. Maybe if you're trying to, you know you're going to retire 30 years from now, and you start putting in these payments for 30 years, the term of that annuity would be 30 years. Okay, now annuities can be used a couple different ways. One way is to accumulate funds. So that's just like what we've been talking about when you're making regular deposits into some savings account or some retirement account. Okay, another way annuities could be used is kind of just the opposite, though, is to pay out funds. For example, once you already are retired, okay, and you receive, let's say, regular payments from a pension fund or pension plan, that could also be considered an annuity. So maybe every month you receive $1,500 or so, let's say. Okay, that would also be called an annuity. Now, in this video, we're primarily going to be interested in this type of annuity, the first kind. Okay, so what is an ordinary annuity? An ordinary annuity is an annuity where payments are made at the end of each period. Okay, so for example, the end of each month instead of the middle of each month or the beginning of each month. Okay, and the frequency of payments is the same as the frequency of the compounding of the interest. So in other words, if you make payments every month, then the interest is supposed to compound monthly. Okay, if it compounds daily, but you're making monthly payments, you don't have an ordinary annuity. Okay, and the reason it's called ordinary is because these are very common types of annuities because they're easy to calculate. Okay, if you have the frequency of payments is the same as the frequency of the compounding of the interest. Okay, also a special note here, an annuity where payments are made at the beginning of each period, okay, maybe the beginning of a month, every month, or the beginning of every year, that would be called an annuity due. So when you see this word DUE, that's what that means. But we're not gonna cover those. We're not gonna talk about those. Okay, so let's do an actual example. It says suppose $1,500 is deposited at the end of each year. Okay, so we're making yearly payments, not monthly ones. Suppose $1,500 is deposited at the end of each year for the next 6 years in an account paying 8% interest compounded annually. Okay, find the future value of this annuity. In other words, how much money will be in the account at the end of the 6 years. Okay, now first of all, notice this is an ordinary annuity. Okay, it's an annuity because we're putting in the same amount every month, right? $1,500 every month. Every year. This is happening every year, and our interest is compounding annually. Okay, also we are paying at the end of each year. Okay, so what we have is an ordinary annuity. Okay, now how much is this annuity going to be worth? Well, let's kind of draw like a timeline here. Okay, let's say this represents 6 years. 2, 3, 4, 5, 6. Okay, that's not very straight, but okay, let's suppose this represents the beginning of the 6 years, and this represents the end of the 6 years. So here's the first year, the second year, the third year, fourth, fifth, sixth. Okay, and notice, when will your first payment be? Well, notice it's not right here. If the first payment right at the beginning, that would be an annuity due. Okay, but you're putting in $1,500 at the end of the first year. Okay, and you're doing that a total of 6 times. Okay, at the end of each year, for 6 years. Okay, and the question is, how much money do you have right here at the very end? Well, notice if you weren't getting any interest, how much money would you have? Well, you made 6 payments of $1,500, and 6 times 1,500 is $9,000. Okay, so I would expect to have $9,000 if I didn't make any interest. So the fact that I'm making interest means I know I should have more than $9,000 at the end of the 6 years. Okay, now how do we figure this out? How do we figure out how much money we have? Well, let's look first of all at this first $1,500 payment. How much will that be worth at the end of this time? And then we'll look at the next $1,500 that we put in. How much will that be worth? And we can add all these up. So let's, the first $1,500, now remember our formula for compound interest was A equals P times 1 plus I to the n. Okay, and we're getting compound interest. Notice we're compounding annually, okay, 8%. So our I is actually 0.08. Now you might think 0.08 over 1. If we were compounding monthly, well, this would be 0.08 over 12. But I is 0.08 over 1, so that's just 0.08. What is the N? Well, for this particular $1,500, the N is going to be 5 because it's going to accumulate for 5 years. Okay, well, it's going to accumulate through 5 compounding periods, okay, because it's compounding once a year, okay, and for the next 5 years. Now, why not 6? Well, because we didn't start here, we started here. Okay, so N is going to be 5. So if we, in the P, of course, will be 1,500. So this 1,500, we plug it in, we get 1 plus 0.08 raised to the 5th power, or in other words, it's 1,500 times 1.08 to the 5th power. Okay, so whatever that ends up being, let me check what it is. Okay, I worked it out and I got $2,203.99. So in other words, this $1,500, it grew over time, right? It grew to be $2,200, over $2,200 at the end of the year. Okay, basically you gained a little over $700 in interest. And each of these $1,500 is going to grow over time. Now this $1,500 isn't going to grow to be quite as much as that first $1,500 because it doesn't have as long to grow. But anyways, that's what we get. But actually, instead of looking at this number, this $2,200 number, I want to look at just the formula for it here. And I want to figure out how much money would we have total. Okay, the total amount we'd have at the end of the 6 years. First of all, it would be this 1,500 times 1.08 to the 5th power. That would be how much this $1,500 grows to. Now the next one, this $1,500, you can see would be 1,500 times 1.08 to the 4th power. Okay, you could work this same calculation again. That's what you get. And the next one would be 1,500 times 1.08 to the 3rd, and then 1,500 times 1.08 squared plus 1,500 times 1.08 to the 1st power, right? That would be this amount right here. And the last amount is really just, I mean, it's not going to grow at all, right? I mean, it's like 1,500 times 1.08 to the 0, but 1.08 to the 0 is just 1, so we could just write plus 1,500. Okay, that 1,500 didn't have any time to grow. Okay, now notice what happens when we add all these things up. What do all these terms have in common? Well, they all have a 1,500 in common. Okay, so let's factor out the 1,500. Now notice, let's actually kind of do this in reverse here. 1,500 times 1, that would be this term. 1,500 times 1.08 to the 1, that would be this term. Okay, and then we have 1.08 squared, right, times this 1,500. Remember, this 1,500 is distributing here. Okay, that would give us this term. Okay, and so on. So we're going to have plus 1.08 cubed plus 1.08 to the 4th, and finally plus 1.08 to the 5th power. Okay, well, if you remember the formula that we had from the previous video, we had this formula. We can find it here. Remember this formula right here. Let me circle it. 1 plus x squared plus x cubed all the way up to x to the n minus 1 equals x to the n minus 1 over x minus 1. Now this x is really just 1.08 now in our video. Okay, and let's figure out what the n would be as well. Okay, so let's write this out. This is really 1,500 And remember, so let me write the formula again. 1 plus x squared all the way up to x to the n minus 1 equals x to the n minus 1 over x minus 1. So notice our n actually would be 6. You might think, well, I thought n was 5 here. Right, well, that's the n minus 1. Okay, what's inside the parentheses here? That's going to correspond to this. Okay, this part here is going to correspond to this, where the x is 1.08. Okay, and the n minus 1 is 5, so n is actually 6. So what we can say is this is equal to this. Right? These two things are the same, so I'm going to put 1.08 to the 6th minus 1 over 1.08 minus 1. Okay, so I used this formula that we had worked out in the previous video to say that this expression is equal to this expression. Now, another way to write this would be 1500 times 1.08 to the 6th power. Okay, I guess I could put that in parentheses. Minus 1. Now, what is in the denominator? 1.08 minus 1, that's just 0.08. Okay, now we could figure this out. Let me do this. Okay, so let's type this into a calculator. We have 1500. Now we have to be a little bit careful about our parentheses here, but times, so in parenthesis, so in the numerator, so I might need to put another parenthesis here. I'm going to put 1.08 raised to the 6th, whoops, raised to the 6th, okay, minus 1. Okay, end the parenthesis, then divided by, okay, and then we'll put 0.08 and end this parenthesis. Okay, and what do we get? A little over $11,000. Notice if we didn't get any interest, we said we'd have $9,000. So we have a little over $11,000, $11,003.89. So let's write that in here. $11,003 and how did I already forget it? And 89 cents. Okay, so that's the future value of this annuity. Okay, the key part though was figuring out that this, when we added up all these terms here, we could use the formula from the previous video. Now, one thing I want to point out is let's look at this right here. In fact, let me put it in red right here. Let's look at this. And let's talk about the formula for the future value of an annuity. This says the future value S. Now previously we've been using A for the future value. Okay, but we're going to use S when we're talking about annuities. The future value of S of an ordinary annuity used to accumulate funds is given by this. S equals R, okay, where R is the payment at the end of each period. In our case, the R was $1,500. The I is the interest rate per period, and N is the number of periods. Well, notice, is this essentially the same thing as what we had up above? Remember, didn't we have that the future value was equal to 1,500? Okay, the R was 1,500 times, now I was using, there's no difference between brackets and parentheses. They're essentially the same thing. But didn't I have 1.08? That was 1 plus the I to the 6th power. Right? So that's 1 plus I to the 6th. And we had a minus 1. And what did we have in the denominator? We had 0.08. Okay? So that was the I. So you can see this formula, this right-hand side of the formula corresponds to what we did here. Okay? But really where this formula ultimately comes from was that the original formula that we had in the previous video. Okay, well this video is already getting kind of long, so I'll do some more examples in the next video.